Welcome back guys. In previous video we discussed about time travel. In today's video we'll discuss that concept in more detail. So it is saying all of the steps after checkpoint ID will be executed, i.e. a new fork, even if they have been executed previously. So what does that mean by new fork? For example, we have this snapshot, and if we take the copy of this snapshot, it is now the new fork from this previous one. Just consider we have this text file, and in this text file you have some data. You will take the copy of this text file, it is the copy of this text file, or it is the new fork. We'll do some changes in this new fork. There will be no changes appeared in previous text file or previous state or previous fork. So you will create the copy of previous state or snapshot and do some changes. It is basically the new fork. After that, it is saying update state. In addition to replaying the graph from specific checkpoints, we can also edit the graph state. We can do this using update state. This method accepts three different arguments. The first one is config. In config there is thread ID and checkpoint ID. We already discussed that how configuration works. And another is values. These are basically the actual values. It is basically the example. We have two parameters. One is foo, it is integer, and another is bar, it is list of string, and there is a reducer function. Here it is saying if foo value is 1 and bar value is a, if we update the state with these values, means it is saying we'll update foo with 2 and bar with b. Our new updated state will be foo will be 2 and bar will be a and b. Mean our 1 will be replaced with 2, but our a will not be replaced with b. Why? Because we used annotated, mean reducer. Let's discuss these concepts practically. Here I import the mandatory things or mandatory libraries, and it is our state. Foo is integer and bar is annotated of list of string. Let's run these blocks first of all. And here I need to define the node. I am saying it will be dummy node and will pass the state. This node will not update the state, so it will just print something like I am in dummy node. It will not return or update the state, it will just print this text. After that we build our graph. I pass the state in state graph, and our entry point is dummy node and exit point or ending point is dummy node. And here I create the instance of in-memory saver. It is checkpointer, and I compile the graph or builder with checkpointer is equal to checkpointer. Let's visualize the graph. Okay, it is the graph. We have just one node, that is dummy node, that will do nothing. It will just print this text. We have starting point and ending point. Now let's use our previous notebook, and here I will copy this cell. Here we create the configuration, and now we have to invoke our graph. But this time I will say my values are these values. Mean foo will be 1 and bar will be a while invoking the graph. It print I am in dummy node, mean it execute this dummy node, and we initialize the value of foo and bar with these values. Let's print the state. Here you can clearly see that foo is 1 and bar is a. Now we have to update our state, but first of all let's list all the graph state. It will print state.next, mean what will be the next node that I have to execute, and it will print the checkpoint ID of each state. First of all, it is saying it is the checkpoint ID, and I have to execute start node, then I have to execute dummy node. After executing dummy node, I don't have any node to execute. Perfect. And if you want to print the states, you can print this way, or I am saying this selected state means state before the last state. State 0 means our new updated state. So it will print selected state dot next, mean what will be the next node, and what will be the values of selected state. It is saying foo is 1, bar is a, means the values that we pass here while invoking the graph, and it is saying I have to execute this dummy node. Now I am saying it is our new configuration. Here we will call this graph.update state function and will pass selected state.configuration, and our values will be different. I am saying these are the values. Foo will be 2 and bar will be b, and it will return the configuration. And now let's invoke our graph, and let's print the state. Foo is 2 and bar is a and b, mean this 1 will be replaced with this 2 and this a will not be replaced with this b. Why? Because we use annotated and reducer here. Here there is another thing, that is as node. The final thing you can optionally specify when calling update state is as node. If you provide it, the update will be applied as it came from node as node. So what does that mean? So it's mean, for example, I am saying as node is equal to this start node. The start node is doing these updates, and it is saying if as node is not provided, it will be set to the last node that update the state if it's not ambiguous. The reason this matter is that the next step to execute depend on the last node to have given an update. Here we specify that the start node has updated these values, and it is saying so this can be used to control which node executes next. But this parameter is optional if you will not specify as node, so you don't have to worry about that one. If there will be some issues, we will see that in future. So for now, that's it guys, and have a great day. See you guys in next video.